let's go ahead and start talking about ML Observability. If you've come to one or two meetups, you know that this is one of my favorite subjects. I talk about it in almost every meetup, even if it has nothing to do with what we are talking about. And today we actually have an expert on it. So I am very thankful for you to be here, just so that everyone knows who is here with us. We have Aparna, and I don't know if I put the accent in the right place. Is it Aparna or Aparna?
It's Aparna.
Aparna. All right. And she is the Chief Product Officer at Arize AI. And their whole thing is ML Observability. So we are in the right place. This is very cool for me. I have been talking about this for ages. And now it's finally happening, which is very exciting. And a little bit of background on Aparna. She has a bachelor's degree from Berkeley Electrical Engineering and Computer Science program. And you published research with Berkeley's AI research group. Not an easy feat. You're on a leave of absence right now from the computer vision program at Cornell University. And before you went off and started working at Arize, you were an ML engineer at, is it Uber? Were you working on, or some of the team? You were working on Michelangelo.
So I started off on the forecasting team and then ended up getting into ML infra, and all the work that ended up working on is Michelangelo.
Nice. Awesome. So just so everybody knows, and so that you have an idea, she has that background. So she's not just talking about this stuff as like hoop dreams, right? Now, please welcome our first guest and last guest for today. We have Aparna, and I'm not going to try and say your last name because it's a long one. It's Dhinakaran, I think is
close enough. Close enough.
Forgive me for that one. But I want to start how I usually start and just ask you about how you got into machine learning, what drove you into tech, where did that whole inspiration come from?
Awesome. Hey, everyone. Thanks so much for joining the talk. Really, really happy to be here. Thanks, Demetrios, for inviting me. I got into tech. I guess I really liked math growing up. So I really wanted to work in a field that touched math. And I felt like machine learning combined, just my love for math and also computer science, which is what I was studying in college. So I got into it pretty early. There was a professor at Berkeley named Alice Agagino who focuses on sort of intelligent systems at Berkeley. And she asked me to join her research team. And so she got me to kind of join my first ML project and research. And I published a couple of papers with her. And I think that's where it kind of clicked that this could be a fun space to work in.
So as far as machine learning goes and what you were doing at Uber, can you give us a bit of background? You mentioned a little bit, but can you go into more depth on that?
Yeah, so I started off on sort of one of the ML teams at Uber, marketplace forecasting, and it was a really exciting team. Lots of models being retrained every single day. Lots of sort of impact. Uber is one of probably the best places to work if you're super interested in machine learning, because one, you get real-time feedback about your models. Models depend on one another. And so it was a really exciting place. And when I started, there were still a lot of tools around the ML infra that were being built there. So I think Uber has open sourced a lot of them, but pieces of Manifold were being built, pieces of sort of the Michelangelo platform were just starting to kind of be fully baked and ingrained into a ton of the marketplace teams. And so it was a really exciting time to join one of the ML teams. And I started off on one of the more modeling kind of teams and then got roped into ML infra, just deploying a bunch of models and starting to see a lot of the pain points. And we started to understand sort of what could make a lot of these teams move faster. And so that's sort of where we started building pieces of the model storage and model deployment that ultimately became a part of Michelangelo.
Awesome. So I have to ask, were you ever working with Kevin Stumpf? Because he was just on the meetup a few weeks ago.
So I knew, I didn't know Kevin. I had known of Jeremy because Jeremy and I had been a part of sort of Uber ML conference. So I knew Jeremy. We were probably in some meetings together around sort of the project I was working on and Michelangelo. And I knew Mike from the Uber ML conferences as well, but I didn't know Kevin that well.
Awesome. Yeah, well, it's nice to see that it seems like you both got inspiration from working at Uber and then said, all right, well, there's a lot of needs that we can see, and maybe Michelangelo isn't addressing some of these needs. So let's go and start our own thing. And along those lines, what was it that brought you into machine learning monitoring and observability?
So it actually took me a little bit to get into ML observability as a whole. And so I think that I first started noticing some pain points around models being deployed into production, and we would always get roped into issues at Uber. You know, there would be some tickets that were happening because ETA was down in a certain area, or surge was up, or some model outputs were being fed into another model, and there was some issues from some downstream team, and they would start bugging us. And so knowing what the models were doing in a production environment was always something that was probably my biggest headache when I was actually at Uber. And so it was something that I'd sort of known was a pain point. I was like, okay, maybe I'll look into it after my PhD. And so I sort of blissfully went into my PhD. And when I was there, I was focused on computer vision. And Cornell has a pretty interesting computer vision program in that it was really closely connected with the fairness in ML group. And so there was a lot of folks who were working on a model fairness and bias. And, Rediat Abebe, who is now a professor at UC Berkeley, was sort of part of that cohort of people that I was closely working with. And so, there's a lot of folks who cared about computer vision, cared about fairness. And I think the more and more I was starting to get into research in computer vision, the more I was just getting pulled into the fairness ecosystem. And that sort of pushed me to think about how can I compare, how can I, bring together this world of fairness, world of model observability, both of which seem kind of connected, models that are in production. And how can I make a platform or make some kind of tool to help bring these issues that folks across the ML ecosystem are seeing. And so that sort of was kind of my like light under my feet or something that got me to just decide I'm going to take a leave of absence, found a company. And so I went through Y Combinator initially. So I went through YC, raised money, founded Monitor ML, and we merged with Arize. And so that's kind of how my journey to starting an ML observability startup came about.
That's so cool. And so we've had a few people talk about why machine learning monitoring is so much different than your normal software monitoring. But I'd love to hear your take on it and what you have to say around that.
Yeah, so that's a really good question. What I always say about this is software monitoring, is model monitoring is just not like software monitoring at all. It's not linear. It's not just code that you need to monitor. It's also the data that's coming in. And so it's a lot more alive and changing than software is. And so you might have a model, but there's input data that your model actually depends on that forces the model to make decisions that if it's inputs to the model that it's never seen before, there's decisions being made. If it's inputs that are changing over time that the model's never seen, there's all these moving pieces that you don't necessarily have the same sort of needs that you'd need in model monitoring as you need in software monitoring. There's more things to look at, more things to monitor, and there's, I think, a general sort of confusion around what do I need to monitor to make sure that the stuff's actually working in production.
Yeah, that makes complete sense. And I know that you wrote an article fairly recently, right, about the whole state of machine learning with the coronavirus and how things kind of have haywired. And I'm wondering if you can go into that a little bit more, because I thought that was an amazing article. I'll link it to the chat right now so that if people want to read it later, they can. But can you
Yep.
just give us a bit more? Yeah.
Yeah, I can. So I was thinking, actually, I have a couple of slides on sort of what I wanted to talk about, and some of it actually cover the coronavirus and best practices. Do you want me to kind of hop into that first, or talk kind of about what is ML observability, talk about sort of what I'm building in Arize, and then maybe hop into best practices and how that connects with the COVID-19 situation article that I wrote about?
Yeah, for sure. Whatever you feel most comfortable with, we don't mind, right? I think it's all good. So if
Okay.
you want to, show us some slides, show us what you got and your take on it.
Cool. And feel free to interrupt and kind of hop in and ask questions. I have no problem with that. So this is broadly what I thought I could talk about today, which is, first just hit on what is ML observability, give an overview of what we're building at Arize for the observability platform, and then just leave you with some best practices on what you could do at your company, what you should be looking out for. And these conversations are happening a lot more just because of the COVID-19 situation that the folks are sort of confused about why their models aren't performing as expected. And so I think, you've probably seen this visual if you've read some of my blog posts around the ML infra kind of tools out there. But, broadly, these are kind of the buckets that I view the workflow in. There's kind of a data preparation world, the model building world, and then production, which is probably what everyone really cares about in the Slack community.
And I gotta just jump in and give you like a big thumbs up on all of your Medium articles, because you have done so much to help people, myself included, understand where all these tools fit in and what this tool would be used for, where it is like, because, and you said it yourself in this Medium article, I think, that you wrote, you've been through a sales meeting with a vendor and you come out and you're like, what do they do? I don't really understand.
It's like the hype is mixed in with everything else. And so I have left being, just trying to understand which bucket do they even fall under sometimes. And so it's confusing. And so thank you for saying that those articles have been helpful. It'll inspire me to continue, keep writing more.
Yes, please. And if anybody hasn't seen it, definitely go out there and read it because they're worth the time.
Awesome. So I think people think about production as sort of, throw the model into production and my job's done. And they can just like wash their hands off and just kind of let it sit there for a while. And the problem with that is, because models are not like software, like linear code, lots of things are changing underneath you. And I've had, some of the kind of company calls that we've been on, and I've had CEOs and data science leaders say things like, spend millions of dollars on machine learning, and I have no idea if it's actually even working. And what that boils down to is really, is the code, is the research kind of model that you're building actually going to work in a production environment? How do you have tools to actually know if your model is working in a production environment? And this isn't just, a single metric like accuracy or WMAPE and, some metrics that people are using, but how do you know if your model is working in this specific state for this specific, maybe set of users who are on this iPhone version? There's just so many kind of sub populations that you want to understand if your model's not only doing well globally, but on these aggregate levels. And if you do kind of, you're like me and you're at Uber and you're just an ML engineer and you're like, somebody's asking you, hey, something's going down wrong with my model, well, can you go figure out why? Where do you even start? Where do you even actually start to understand what's wrong with my model and why? And how do you root cause issues that are coming up with these models in production? And so to everyone who kind of just like washes their hands off after putting the models into production, they almost immediately enter into like one of these scenarios, which is like, what is going on with my model in production? And so this is, I think, sort of really tied to the way that we think about the software development lifecycle and the way we think about the model development lifecycle. Software world, tons of tools to actually help you do the testing and integration and monitoring of it in production. Model development lifecycle, not so much. There's not a lot of tools to actually help you validate that the stuff that you've built in this, researchy, Jupyter notebooky environment is actually going to work in a production ecosystem. And when it's actually in production, there's not a lot of great tools to actually help you monitor this model is doing what it's supposed to be doing in production. And so all of the stuff that people are asking questions about, like how do I catch drift? How do I catch distribution changes? What about black box models and data quality issues? I think these all stem from the fact that we just don't have great tools to monitor models in production today. And so, I think some of the questions you had sent me, Demetrius, about, folks are asking, what do I even look for when I need to monitor a model? These are kind of a broad set of issues that folks have told us and we've experienced just personally in having models in production and seeing that there's kind of unseen values for a feature that's coming in. How do you find that? How do you even know that it's happening? So these are kind of a broad bucket of issues that we've identified.
And I think there's also something that you addressed in that blog post, which I thought was really fascinating. And it was who owns the model and who owns this whole thing. It's like not really technical, right? It's more of an organizational problem. And it's saying, okay, once it's out in prod, then who's the owner of making sure that is right? Is it the ML engineer? Is it the data scientist? Is it, a DevOps person? Who's the person that has to be in charge of all that?
Yeah. Yeah, that's a good question. And I think that in some companies we've heard it's kind of a you build it, you own it kind of model. The data scientist who builds it actually owns it in production. And in other companies, it's, the data scientist might not even be an engineer. I mean, there were some data scientists on my old team at Uber who were chemist PhDs or physicists. And, they were great with sort of building models and they wanted to it was tough getting them to leave R or MATLAB. And so getting them to write production code was going to be a kind of whole other ballgame. So, there's in companies like that, they have kind of these hybrid kind of engineer data scientist folks that are called ML engineers who have some background in machine learning, some background in software engineering, and can actually put these into production. And it's still tough. Is there a model owner who actually is responsible for catching issues? And I think that, there's, the state of the art today, really what folks are doing, if they're a pretty good team, they probably have at least some kind of workaround, some kind of monitoring, they're using some kind of super monitoring tool to at least answer some of these questions. So something like Grafana that Lena was doing in her talk, where she had set up some metrics and, see an ML engineer or a data scientist could at least go and look at that. And then in other cases, it's really just some kind of scripts, Python scripts lying around. Somebody says there's an issue, they'll run sort of fetch a bunch of data from Hive or whatever, run some evaluation metrics and try to understand what was going on. And so those are kind of the, when we've been talking to folks, those are kind of the workarounds people have been doing to actually monitor their models in production.
So that's where we're at right now, basically.
That's where we're at. And so that's sort of like where, Arize is coming in. And our goal is, you should actually have an observability platform for monitoring your models. And so, this is just want to give overview of Arize a little bit. I think that, if you're interested, I'm not going to share a lot because I think that I want this talk mostly to be about best practices and what are the tools and tips. But I do want to give you sort of a little overview of what a tool like this can actually help you do that you might not be doing already. And so team, just a quick overview on the team. Teams comes from places like Uber and Google and Facebook, and folks have actually built large scale analytics platforms. And so probably deployed, the team itself has probably deployed over thousands of models into production and can handle scales of sort of millions of predictions per second. And so the platform itself focuses on model validation. So actually answering the question of, run a bunch of checks before your model goes into production. So and you have a sort of reference distributions and reference sort of checks of how your model is performing in this sort of trained environment. And then when your model is actually deployed into a production environment, real kind of alerting and monitoring tools so that you can deliver your models like you deliver software with continuous monitoring and checks. And then we have a set of tools to actually, we tie in sort of troubleshooting and explainability so that when there are issues that are going wrong with your model in production, we actually help you root cause and understand what went wrong, why, how can you sort of catch these faster so you're not writing a bunch of scripts like people are doing today. And so I'm going to give you, a little, preview of Arize, little peek into it so that you guys can kind of just understand a use case of how someone in a real production environment would monitor the situation. So Arize captures the inputs of the models and the outputs of the models. So the features and the predictions and the actuals. I think Lena mentioned in her talk that you should definitely capture the inputs of the model. You should also capture the predictions. One other thing that I would add is the actuals. I think that people today sort of, the actuals are sort of the truth events that happen. So if your model is predicting fraud or not fraud, you might get back the real sort of, was that transaction a fraud or not fraud, anywhere between 30, 60, 90 days afterward. And so that event sometimes just lives in a separate database, separate sort of environment from the actual sort of model inputs and outputs. But what you really should do is connect those actuals back to the predictions so that you can build these metrics and you can have these kind of performance tracking and alerts. And in some cases, I mean, on some teams that I worked on at Uber, it was sort of almost instantaneous. You got these actuals back. And in some companies we've been talking to, it can take sort of an extended period of time. And so you need a way to actually tie this back together.
Wow, that's such a good point.
Yeah. And, the monitoring platform that you're using ideally shouldn't be something where you're building a new dashboard for every type of model that you have out there. I see this so often, you have a dashboard for model X because it was on TensorFlow. You have a dashboard for model Y because it was built on some kind of custom home built thing. You have another dashboard for this, and you just have different platforms and different tools you're using to monitor all of this. Ideally, you have one kind of coherent place, consistent place where it works for any kind of model that you're building across any kind of platform, any kind of frameworks that you're actually using. And so with that, I'm going to kind of hop into just what our product looks like, and set it up a little bit for you, so that you can just see what a platform that's focused on model monitoring looks like. And so this is kind of how you would integrate with our platform. Simple integration. You can use our SDK, send in the sort of inputs to the model, so the features. You can log in the predictions, and the example model that I'm going to walk you guys through today is sort of a fraud detection model. And so, this person's applying for a loan. Is their application sort of a fraud or not fraud? And so the data that we built this model on was from Lending Club on a Kaggle data set. And so the inputs of the model include things like purpose, purpose of the loan, the loan amount, the state that the loan came from. So a bunch of different features. And it's a multi-classification problem, models predicting fraud, not fraud, or unknown. And, let's just pretend we're all sort of ML engineers right now. And let's just put on our ML engineering hat, and we're getting a bunch of tickets. People are asking us, I got a PM who's coming to me and saying, hey, Aparna, I'm getting a bunch of tickets. There's a bunch of sort of fraud cases, fraud misses that we're getting in California. Can you go take a look? And so I need to go and look at my model and understand what, how can I debug this issue, understand, maybe confirm that this issue is happening, and try to figure out why it's actually happening. And so I'm going to hop into kind of a demo of the platform. I set this kind of dashboard up a little bit beforehand for you folks. And And again, I'm only going to show you kind of a bit of a sneak preview of Arize. I'm not going to show you all of the other we have a bunch of other pages, like things like deep dive and alerting and tools, but I'm going to kind of just show you a little snippet of it. And if you want to talk more about it, you reach out to Arize and we can talk to you about it. But just quick view. So you're now in your dashboard that's focused specifically on your loan fraud model. You have a quick kind of overview of sort of what are your evaluation metrics for that model. And today's state of the art is really just you're looking at one metric, something like accuracy, and you're trying to understand, hey, what's going on? Where's this issue actually happening? And you might have a little kind of, sorry, let me zoom out of the way so I can actually move this around. Oops. Okay, so you might have something like a single kind of view of an evaluation metric, and you're trying to understand what's going on here with this model. And so in this case, we have a little bit of insight from sort of the folks that sent us the ticket. We know that there might be an issue in California. And so real quick off the bat, I just want to understand, how is my model doing in California specifically? So I can go in, I can pick sort of an input to the model, which is a state, and I can filter it on California. And all of my evaluation metrics are sort of updating. I have sort of the main graph that I'm looking at for accuracy updating when I look at that specific slice of accuracy in California. And here I can almost quickly tell, okay, there is a dip. Like the tickets aren't crazy. Someone's telling me that there's an issue, it might be in California, and I'm looking at the date range and somewhere between the 14th and the 15th, something's going on here with my accuracy of my model. And so I want to zoom in a little bit, look at just that date range of the 14th and the 15th, and there's an issue. And so what I could do right now is, let me just to kind of clarify that this is happening, I might want to compare the global view of accuracy with just sort of the kind of local California view. And so I'm going to go in, I have set up a plot that looks at accuracy just overall, but now I care about California accuracy. And so I go in, I set up sort of my loan fraud model, pick the version that I care about, set up sort of the evaluation metric that I want, and I can set up a filter on the specific state that I care, or the specific slice of data that I care about looking at, and just confirm that this issue is actually happening. So here I have a view, okay, tickets are coming in, I've confirmed, I can go to my PM and say, okay, the person isn't crazy, there's actually an issue here with California. But I haven't really solved the issue. So what's actually going on here? Like, why am I seeing this? And this is where knowing sort of the, inputs, outputs, the actuals really matters to get to the heart of how do you actually solve an issue like this. So now, what I want to actually compare is just, I have a view into what are my predictions versus actuals. So what was my model predicting versus what actually happened? So here's kind of, predictions that my model is saying are fraud, and here's what's actually fraud. And I have this view on a global level, but I might want to just look at California and try to understand, where am I going wrong? Do I have a lot of false positives? Do I have a lot of false negatives? What sort of, if I specifically look into California, what am I going to get? And so I'm going to go in and set up sort of predictions versus actuals, looking just at California. Pick predictions. I can pick the model again that I'm looking at, distribution over the predictions. And here I go ahead once again and just pick the filters that I care about on the slice of data that actually matters to me. And so this is my sort of predictions in California only. And now I'm going to set up kind of an actuals. So I'm comparing side by side predictions versus actuals, set up a distribution over the actuals, pick my model version again. So you can filter by any kind of model version that you're actually sending, which is really important because if you're actually building a ton of models, you might have multiple versions in a true production environment. At Uber, my old team, we were spinning out a new version of the model every week. And so you're going to have a ton of these new versions. And so, okay, let's go back to our story. So now I'm comparing side by side predictions versus actuals global, predictions versus actuals California. And straight from the bat, I can see, okay, just seeing them side by side, there's something wrong here, because just the comparisons between the actuals and the predictions, I'm clearly predicting more kind of fraud in California than I'm actually doing on a global level. And so now, if I'm just building the funnel of how I would troubleshoot this issue, first, I've narrowed down into kind of issue in California. I know the date range that the issue is happening in. I know what I'm doing, lots of false positives. And now I just have to understand why. Like, why is this actually happening? Like, what's changing that's causing my model to do this? And so, I did pre-set up kind of, as I was building up my model, what are the most important features for this model? What actually, what are maybe the top 5 features that this model looks at and could be influencing the model in a really big way? And so, its interest rate, its purpose of the loan, the state of the loan, home ownership, things like that actually really influenced my model. And so the next thing I want to do is just compare, did anything go crazy between when I built my model to now? And so this is, I think Lena mentioned this in her talk and someone asked a question about it, but reference distributions are really important to knowing, did something actually change from when I built this model? And so in this case, I'm going to go back and just try to see if any of these features change when I filter on California. And in this case, like, I don't know if you guys saw that, but there's kind of 3 tall, bars on purpose now when I look at California. But when I was looking at a global level, there was kind of only 2 bars. So for me in my head, I'm like, okay, this is kind of something that I might want to go and actually try to understand if this looks different from my sort of validation environment. And so I'm going to go in and just edit this dashboard and edit this specific kind of distribution view and try to understand if there was a change between the training version and the one that's in production. And so I'm going to call this one my training distribution. I'm going to look again at the loan fraud model, this time specifically at sort of the training validation set that I care about. Look at the distribution of the same feature, purpose. And in this case, I can see that when I actually went and trained my model, I didn't have sort of a, whoops, did I add the version? Let me make sure I added the version just to make sure I'm capturing it. Okay, so training, I have my loan fraud, looking at this, I'm gonna go ahead and save. Okay, publish changes. So when I actually trained my model, I didn't really have any kind of values for tax payment as one of the feature values for this feature, but I'm seeing it in production. And so this is kind of a use case where I've caught a new kind of value for a feature that I'm seeing in production that I haven't seen in my training environment. And so I can verify this by just going in and checking, I'm gonna build a quick little statistic widget and see for this specific slice that we've identified and troubleshooted today, which is, my loan fraud model, specific version of it. I'm picking the set of sort of the set of, predictions that are happening from California, from specifically the purpose of the loan is tax payment because, the COVID-19, the tax payment got delayed. Then I can tell that my accuracy is sort of much lower than the global accuracy that I have over here. And so this is kind of a way that you can go in, slice and dice, and look at sort of all of the different, subgroups of the model and try to compare predictions of the model. And so I hope that was helpful, but that was kind of like a quick view into like how you could use a platform like Arize. And it's a super kind of quick example, doesn't even cover all of the deep dive features, but gives you a view into how you could use a ML monitoring platform.
That's very cool. Thank you for showing us that. And I was going to mention, I didn't think that the model was off because I knew that Chris was visiting California during that time frame that you put. So I thought maybe the model was actually doing its predictions correctly.
Oh, wow.
Yeah, everybody's on mute, so I can't hear if anybody's laughing, but enough of bad jokes. I want to ask some of the questions that were posted in Slack, if we can. Or do you want to continue with this best practices, and then I'll do some of the questions in a minute?
Um, sure. I mean, we can, maybe I'll just kind of try to run through some of this and then answer some questions. I think a lot of the stuff that the folks, I wanted to kind of talk about, you mentioned it was like, how does this relevant to today's time, which is a time of coronavirus? And, everything's kind of different than it was a couple months ago. A lot of inputs to the models are different. Unemployment numbers are kind of, 25 plus sigma events. Traffic has totally changed. We're now at like 1 to 10% of daily volume before COVID. And so you might, some of the folks we've been talking to have been saying things like their predictions have been really off. Weather predictions are off. Bank models are sort of off right now. And so I came up with kind of a list of sort of best practices from when you're monitoring models, input level monitors, model response level monitors, and kind of extreme environments. And so I can just leave these slides up or kind of talk through them maybe after we run through the questions from Slack.
Yeah, so the first one from Slack is from Venkata, and he's asking, in your experience, how fast do models degrade? Do you have any data points or observations on that?
So this question is probably going to change depending on the model, which is, if you're, and it's also going to change based off of the, length of historical data that you probably trained your model on. And length of historical data is kind of a proxy for maybe, how varied the data that you've captured in your training environment really is. So if you've captured a lot of different scenarios, your model might be resilient enough to handle unique situations that are coming up and might be able to handle any kind of, long-term changes that happen. It just really depends on the model type, to be honest. I think that it depends on the model type, depends on the model, depends on the data that it was trained on.
And so how deep should the observability be? Like, does the data capture process need observability? Does model state need observability?
Yeah, so I think that, the inputs of the model definitely need to be captured. The outputs of the model definitely need to be captured. I think, finding a way to get some hints about the actuals or the truth events is really important. If you don't actually have the actuals, are there any proxy metrics you could use to get the actuals, to give you some kind of insight, on sort of a periodic basis. And then in terms of model state, I think that, there's kind of a, depending on the ecosystem or the deployment, sort of infra that model is deployed in, that also needs to be monitored, right? I mean, if there's input data that's coming in that's different or some kind of upstream data quality issues are happening, it's going to impact the model performance. And so there's like all of the surrounding kind of cloud around the model. It would be great to have, it would be great to have observability around all of that. I think you specifically at least should start by focusing on monitoring the inputs and outputs.
Great answer. Yeah, that's something that Shubi Jain told us too when he was here months ago at Data. What is it? SurveyMonkey. They double checked with the actuals just to make sure they were doing the right thing and what their assumptions were actually correct, and tried to look at that as much as possible. And so I see there's a question here in Slack from Amy, and I see Amy is actually with us today, and she's asked a bunch of questions, but I feel like we answered most of them, Amy. So if we didn't answer some of them, can you just go ahead and throw in the chat now, like an updated question? Because she's got quite a few, but I think we may have gone over most of them. So I'll give you a minute to throw it in the chat and or unmute yourself and ask the question. I had the question about if you're getting, so I know that with like software monitoring, you can be thrown into like a alert hell where you're just getting
Mm-hmm.
alerts all the time and you feel like, oh my God, everything's on fire. And really it's not. So I'm wondering how you go about that within the machine learning monitoring.
Yeah, that's a good question. I think that, alerts, if not set up properly, can suck because you're just going to get paged in the middle of the night. No one
Yeah.
wants
And
to
you're
get up
sweating.
yeah. I think that there's sort of figuring out the boundaries of, what are the boundaries of sort of your model performance that you're okay with is going to need some kind of testing. And so for some folks, if their model performance dips 5%, 10% over the course of a week, maybe they're not super worried. But if it dips kind of maybe 20 or 30%, then that's kind of a cause for all hands on deck. And, in other cases, it's even more, kind of that interval is much smaller. It could be 1%, it could be, 5%. And so that interval that you actually care about is something that is very kind of model specific and needs to be kind of fine tuned, understanding, what is an actual metric that you think is sort of useful enough to be alerted on. And I think that, it's not only the evaluation metrics that you want to be alerted on, it's also, the sort of inputs that are coming into the model that you might want to be alerted on. If you're getting a ton of new features for a model that you've never seen before, and that signifies something else has gone wrong, you might want to be alerted. And you, maybe alert is sort of the bad term. Maybe you want to be notified. And so, that way you get an inkling that you might want to look into this, but you're not sort of just paged out of it.
Completely. Yeah. So Amy threw in the chat, she is wondering about some open source tooling recommendations. I know you had already mentioned Prometheus and Grafana, and I feel like that is kind of industry standard. Do you have any other ones that you could recommend?
I think that those are probably some good ones. I think that if you're using kind of Prometheus and Grafana to do model monitoring, Amy, I'd love to talk to you and see if there's a way I can get you to use Arize and kind of curious about the open source part. If it's kind of just you want to deploy it in your own environment, there's kind of different deployment things that we offer. So you can deploy on-prem and stuff. So I'm curious to know about the open source part, but I can follow up with Amy offline.
Awesome. Yeah. And anybody else who is interested in that, for sure, reach out. So I know that you have some war stories, and I would love to hear them. Can you give us some just times where a model went awry and nobody caught it, and then it lost the company a bunch of money, or any other story along those lines?
Yeah, okay, so I don't know if I can give you details,
No
but
names, none
just
of that, but just, yeah, tell us the gist
yeah,
of it
yeah.
maybe.
So I mean, yeah, I mean, no names or details, but I guess almost like one of my first months when I joined Uber. It was kind of a new feature that we put out, and the feature, was emitting some values that was being fed into a model. And no one caught it for a week or 2 weeks. And, there's this new value that was being seen for a model that no one had kind of noticed any difference. Model performance was like slowly declining. Like if anyone had a graph of sort of just model performance that they were kind of looking and monitoring at, it was like a super slow kind of decline. And at some point, that impacted some other downstream service, which is how all the stuff like you actually figure it out is if you aren't tracking the actual model performance, it's either and it's actually crucial to you, it starts to impact some other product features. And so this model was kind of impacting. I think it was impacting a feature and in the actual core Uber app, and it was like all hands on deck. Like everyone from the VP of the org that I was in, like we were up 11. There was like a SWAT team that was sent in. I was up all night, like pushing in like features to go and like change this kind of observability platform that we were building to get this out to them. And it was nuts. It was like a couple of days of just, everything was on fire. And it was literally because there was new input to the model that we just hadn't seen before. And it was impacting sort of model performance. And so it's kind of vague, but I kid you not, this story that I'm telling you is probably cost, Uber in the land of like a couple millions of dollars. And so it happens all the time. It's super, super crazy. Just the amount of things that happened before there was actually some kind of health monitoring platform that was set up to catch these things.
Yeah, it sounds painful, but it sounds very familiar to what Flavio was talking about when he was on here. And he said, he had some recommender system that gave the same recommendation for 18 days straight. And who knows how much money that lost them. But everyone, no matter what they bought, saw like green shoes, women's green shoes. And it didn't matter if they were buying a car or a house or whatever. I mean, I don't know if you're buying all that on the same platform, but you understand what I'm trying to say, I think.
Yeah.
So,
Yeah.
so it is like that. And in this case, it's really interesting to me how it was a very slow burn, but then once it hit, it was just like working overtime for 3 days. And so you saw all of that time that you could have potentially caught it, and then nobody would have had to have known about it. It would have just been like your team's inside thing. Then it got raised up high in the placement. So along these lines, I'm wondering if you have been seeing any kind of like how in the different sectors that you've been working with, have you seen certain verticals that have more models in production than other verticals, and how do you see like the maturity of the different sectors?
Yeah. So I think that there's kind of the sector that I would say probably has the most kind of rigor in the sort of testing and, monitoring of the model. Maybe not monitoring in production, but really testing of the model is probably the banking industry. And so there's actually kind of regulation, SR11, which really is around how do you validate the model before it actually goes into production. And so, some of the people that we were talking to were saying, it takes maybe 3 months to build the model, 9 months to validate it. And so a year before it actually gets into production, which is crazy. That's kind of the turnaround because, I think I just came from a much more fast-paced environment. So you could build a model, put it into production. And so I feel like the banking industry in general puts a lot more rigor into, validating the model before it goes into production. I think that there's some of these more regulated industries, think kind of fintech, hiring platforms, things like that. There's a little bit more need to kind of check the model's predictions. And so there's more kind of, the Fair Lending Act, and there's kind of, no bias discrimination in hiring. And so there's kind of things that are maybe industries that are a little bit more regulated, care more about the actual monitoring piece.
And when do you feel like a company decides to go out and get a monitoring solution? Like, when does monitoring become so much of a pain that they're just like, all right, we got to do something about this? Is it after you have these huge problems where a monitor goes haywire, or is it before that and it's just because they see that there could be these problems?
I feel like I wish it was the latter. Because it's almost crazy. No one probably deploys software today without some kind of monitoring in place, right? Like you'd be crazy to go do that. And I mean, you'd be called like a bad engineer for doing that. But you don't really get that same kind of thought process when it's sort of for models. And so ideally, it just should be part of You have a model, you're going to put it into production. It matters to you. It matters to the business. So you should monitor it. I think that just even one important model actually impacts customers. You should probably look into either building a monitoring solution or trying out a ML monitoring platform. If you have more than one, multiple models, I think it's just the amount of work that it and the amount of time that it ends up taking from a person who's actually building the models. They could either spend time building new models or improving existing models instead of time spent just on operational issues, debugging issues that come up in production. And so you have these like very expensive people that you've hired doing things like null quality checks, like null checks.
Amazing. Yeah. And it's such a good point. Like we're past that, right? With software engineering, you would never think about not monitoring. But why is it that we aren't there yet with machine learning? So I see Steve has asked something in Slack, and he's asking, model explainability has been around for a while. For example, model governance in banks, such as SR11 that you mentioned. Though often the models they're evaluating are linear logistical regressions, e.g. for credit risk, though increasingly machine learning. How many of your Arize use cases are just machine learning or superimposing machine learning sets on top of other model suites?
That's a good question. So I think that there's probably a couple of questions in there. One is like explainability, and how does that play into this kind of platform? And second is, there's kind of a set of models that folks are using that are maybe more analytical, and then there's kind of a set of models that are really kind of machine learning focused and complicated and so to answer the first question around sort of just explainability, there's certain things. I think we broadly think about explainability as this kind of super complicated thing. There's certain kind of concrete things that we want out of explainability. We want to know things like, what are similar predictions to this prediction? What are sort of the top kind of, reasons or sort of features that may have mattered, and maybe some of the metrics, things like Shapley values and Lime values that actually hint toward feature importance for the specific local prediction. And so there's some concrete things that people want in terms of explainability. And then to answer kind of the second part of his question around analytical models versus kind of machine learning kind of models. So Arize is mostly focused around kind of the deep tech machine learning models and really monitoring and observing those. There are probably ways that you can stick in sort of analytical models, and as long as you pass in the input and the outputs, there are ways that you can use the platform for those types of models. But yeah, I think we're trying. The goal of sort of the platform is really to be agnostic of all model types. So it shouldn't really matter what type of model you're building. We handle kind of the kind of observability piece.
Awesome. So looks like our time is coming to an end. I want to say thank you so much for coming here and talking to us about machine learning, monitoring, and observability. It's something that really, for me, it feels like where we're at right now. I know that when I was at Dot Science, a lot of people were talking to us about it and how big of an issue it is, because it's almost like in the MLOps space, you figure out first how to deploy the model. And then, like you put, I think in one of your Medium articles, that day two. So now what? I deployed it, and what do I got to do? Like, how do I make sure it's working? How do I manage this whole thing? So it's really good to hear you tell us your view, some best practices, what you're doing at Arize. I really appreciate the breakdown and showing us what you have going there. And anybody that wants to check out Arize more, please reach out. I think that's about all I've got. Anybody who's not in the Slack, join the Slack, because I know you are active in the Slack and you help people out. If anyone has any questions, we can follow this up in Slack. I will see you all later. Big thank you again to Aparna, and have a great
Thanks.
day, everybody.
Thanks for
Yeah.
inviting me. See y'all. Thanks, everyone.
See ya.